Hello, good evening. My name is Yuriy. I'm from Albridge, and yeah, it was a long day. Thank you all for coming. I will be talking today about about Albridge and how we did cross-chain transactions with the XRPL. First of all, a couple of words about Albridge. We are a cross-chain bridging provider. We've launched a bit over a year ago, and since our launch, we've bridged over $6 billion of value between the blockchains, processed more than 500,000 transactions, and we've covered a lot of blockchains, most of the EVM ones, a couple of non-EVM ones like Solana, like the Near protocol, like Terra. Yeah, Terra was a big deal up until a couple of months ago. And we are working on some other non-EVM blockchains like Tezos, which is currently in audit, Waves, Stacks, and Casper. And that gives us some unique perspective regarding the cross-chain world. So, and we've been given an opportunity to build a bridge to the XRPL at the end of last year. We've actually launched the first bridge to the XRPL, to my knowledge. And we've joined the XRPL with the family of blockchains we have. And yeah, because of the architecture, we can bridge any direction to any direction. So any of the blockchains we support to the XRPL and vice versa, and also like any subset of the chains. Before I continue with the details about the XRPL implementation and the challenges, let me cover the basics, how the bridge works. This is the architecture common to many bridges, and Albridge is not an exception. Well, everyone has the differences, but that's the gist of it. So the bridging typically involves two smart contracts, one on the sending side and one on the receiving side. And what's happening, the users deposit their funds to the smart contracts on the sending side, specifying the destination chain, specifying the destination address, of course the amount and the token itself. And the smart contracts on the sending side holds those tokens, either holds them or burns them if it's the wrap token case. And the next step is the validator service. So what the validator does, the job of the validator is to guarantee finality of the sending transaction. And this service works differently for different chains. Some chains look for the number of confirmations, so the number of blocks. Some of them look for status of the block. Some of them look for the status of the transaction, specific transaction. So that's the job of the validator to run this blockchain-specific code and guarantee finality. And at the end of it comes the message that, okay, this transfer has happened of specific amount of the specific token to the specific chain to the specific address. And the validator adds a signature to this data, and then this signature and this message can be submitted to the smart contract on the receiving side. So what the job of the smart contract on the receiving side? It does basically three different things. Thing number one, it checks the validity of the signature. So the signature is valid and the validator service really signed the transaction, not the transaction, the transfer. Then it saves the signature as used, so it marks as already used signature. Why? Because we need to keep users and malicious actors from reusing the same signature several times. It can be used only once. And the third thing it does is actually transferring funds to the user, to the recipient on the receiving side, either transferring or minting new tokens if we are talking about the wrap token. So that's how it typically works on the typical blockchain with smart contracts. Now, regarding the details of the XRPL implementation. So if we are talking about the bridging from XRPL to any other blockchain with smart contracts, well, it's fairly similar because instead of the smart contract, which holds the funds, it can be just a regular account holding the funds. And what we need, so the user does a regular transfer, the regular payment transaction on XRPL. So the user needs only to specify the destination address and destination blockchain, and a regular payment transaction on the XRPL has these fields that can be used for this. So there is an invoice ID field, which is 32 bytes, and like any known address on any known blockchain can be encoded there. And there is a destination tag field, which is 4 bytes, and we can encode the destination blockchain. That's all. Sending from the XRPL is easy. And the validator then checks the XRPL transaction, signs it, and the smart contract on the receiving side on other blockchains validates it, and so on and so forth. But what happens when we send to the XRPL? This smart contract on the receiving side with its job of 3 different things, it cannot exist on the XRPL in the current form. So what did we end up with? We ended up with the concept of the intermediary smart contract. So instead of making the XRPL the destination of the bridging, we use a different blockchain, a blockchain with smart contracts. And in this current case, we use the Near protocol, but it does not have to be Near protocol. It can be any other blockchain. Let's see how this architecture works with those 3 things that the smart contract on the receiving side should do. Can it validate the signature? Yes, it can validate the signature because the framework, smart contract framework on the Near protocol is Turing complete, and there are cryptographic functions for validated signature, so this works. What about storing the fact that the transfer was completed? Also can be done because, there is storage options there on the smart contract, so just storing arbitrary data. And the third, can it transfer funds at the end? Well, this it cannot do because it's a smart contract on a different blockchain, and it cannot transfer funds on the XRPL. So, but what can we do here? There is an interesting, let me remind you about the sequence number on the XRPL. So what's the sequence number? If you don't know, each account has a sequence number of the outgoing transactions, and this sequence number is incrementing and it cannot be reused. So if we issue to each transfer, cross-chain transfer, a sequence number, and then it cannot be reused, it cannot be sent again. So that's what we do. We issue a sequence number to each transfer. We save it on the smart contract on the Near protocol. And like the final step of the funds transferring is the relayer, which is a pure backend process which looks to the smart contract on the Near protocol as a source of truth. It can read the destination address on the XRPL, the amount, the tokens, and the sequence number. So it creates a transaction and pushes it. There is no need for it to make sure it happens only once, because it will happen only once, because we have a sequence number. If we do the same sequence number twice, one of the transactions will fail. So that's what we did, and that's how Allbridge works. What does it mean? How can we expand this? Well, it's a very interesting question, because here is an example of like another way of bringing application logic off-chain for the XRPL, which works well, additionally to the other things like we've heard for the last couple of days about the hooks, about the side chains. This is a similar concept, but actually hijacking the capabilities of already established blockchain and moving the part of the application logic there. So not on your backend, but on a different blockchain. So you can see this used as regular AMM, stable curve AMMs, the lending protocols, the staking, the farming, like all the DeFi stuff with the application logic working on other blockchains and the liquidity taken from the XRPL. So this interesting hybrid. A couple of words. We are working on the framework for developers to make easier build similar things, because we've stumbled across several stones when we implemented this, and it involves many moving parts. So we are working on a framework to make easier for other developers to do the same, and we'll be updating you in the future. And this is it. Contact details, website, Twitter, Telegram. Yeah, those are supposed to be links, of course. So just visit allbridge.io and all the links are there for you to click. Thank you, and please feel free to ask me if you have any questions. Oh, thank you. Please, gentleman with,
So, a long time ago, there was, on the XRP ledger, there was things like Interledger, and they were doing demos of cross-chain transactions happening. And my understanding was it was using kind of the escrow feature, the pre-image kind of field, the escrow feature. Is that not possible in this case? Is there a reason that doesn't work? I'm not sure exactly.
I'm a bit fuzzy on the escrow, but when we researched the architecture for the XRPL, we looked at the escrow feature, and we actually talked with the Ripple developers about it. But it lacked some things that we needed, so it is a bit different. And we have more. Well, it is similar, but this is more expanded, more like there is more possibilities in this architecture, and that's what we needed. Right. You're right. Yeah, you're right. Please, yeah.
Thanks. What's your opinion on trustless bridges?
This is a rabbit hole. Because the bridges are, I dare to say, the most hacked infrastructure currently. We've been blessed just with a couple of those, and they were mitigated, so like the losses are not too big. I don't want to invite any other hackers to try, of course. There is a big possibility that we are actually at Allbridge. So our current product is mostly centralized, but we are working on several other bridges, and one of them, Allbridge Core, which we will be launching later this September, actually uses the concept of we are the bridge, but we do not. So the bridge is completely trustless. And we use the messaging protocols for transferring cross-chain data. So basically, the message of the fact that the transfer has happened is sent by the other protocol we are not affiliated with, and it's distributed. So there are many actors playing. So we are working with the wormhole. We're also talking with Layer 0 and like others. We want to be cross-messaging protocol. But the bridge itself is trustless. So we are basically shifting the responsibility to the messaging protocol, but the messaging protocol also can be theoretically hacked. And well, we have not still found the ideal solution for the trustless bridges, but we are going there. We are going to this direction. Yes, please.
Talk a little bit more about why you guys used Near.
Well, we got a good relationship with Near Foundation, and it was actually the previous blockchain we added support for. So our engineers were fresh from this Near experience. It was not the flawless experience. Please don't show it to the Near Foundation. But there were challenges. But since we just resolved those challenges, we were eager to apply this. We are actually working on the more wide approach with the similar version, but with EVM. So because 8 out of 10 blockchains are EVM compatible, that's easier for the users, for the developers to implement. But yeah, Near is at the end except for those things. Near is quick, it's cheap, and well, so far reliable. And we've been looking for quick transaction, fast confirmation times. So that's why we chose the Near protocol in this case. Yes.
Have you tested scalability and performance bridge?
We did. Well, we didn't do like 1 million transactions or even 100,000 transactions. Mostly we focused on the conflicts, because that's the weak point when a bunch of transactions processed at once. But because we move through the smart contract, and smart contract resolves those conflicts. At the end, we've got already assigned sequences. So we've got, well, we had like hundreds of transactions per minute, or more than required for now, but well, not the bottle, like not the weak point, this is smart contract, but of course, the slower the smart contract, the slower will be the bridge. Yeah, it slows things down. Of course, if you will use like a regular database, a regular backend, and that's actually also the way to do this. You can work without smart contracts here. Why we chose to do smart contracts? Because it brings more transparency to the process. It shows our accountability, basically. Like, this is how it looks internally, because if we had a database, it can be tampered with. It can be like any other way to do the database. So that's why we chose smart contract. Of course, it's slower, but it's true way, decentralized way. Thank you very much for your attention, and yeah, please visit our website. Thank you.